Next, I want to talk about the derivatives of exponential and logarithmic functions. Everybody's favorite type of functions. I'm actually a really big fan now. I wasn't so much when I was in college or in college algebra, but now I'm a big fan. So let's find their derivatives. I love the derivative of the natural exponential function. Here's why. It's just itself. The derivative of e to the x is going to be e to the x. It's really cool. So if I take the derivative of e to the x, that's going to be the derivative of e to the g of x times the derivative of g prime of x. So if I want to take the derivative, oh, I'm getting excited, guys. Okay, if I want to take the derivative of e to the x, that's going to be e to the x times the derivative of x, which is 1. So it's just e to the x. Yay! Let's use a more complicated equation. So the derivative of x equals, in this case, my g of x equals 2 of x. So I have e to the 2x times the derivative of 2x, which is 2. So my final answer is 2e to the 2x. Let's do another one. So if I have the derivative of e to the 4x squared, that's going to be e to the 4x squared times the derivative of 4x squared, which is going to be 8x. So my derivative is 8x e to the 4x squared. We can do the same thing with tangent and any other assigned functions. I have e to the tan of 2x. Then I need to find the derivative of tan to the 2x. Well, the derivative of tangent is secant squared. We've got to use our chain rule, right? So I've got secant squared of 2x times the derivative of 2x, which is 2. And then we might want to rearrange this a little more nicely, don't we think? Beautiful. Next, I want to talk about the derivative of the natural log. Derivatives of the natural log are 1 over x. So if I have f of x equals the natural log of x, my derivative is just going to be 1 over x. If I have the natural log of a full-fledged function, not just x, right, whose derivative is 1, so I get 1x. We're going to want to use this form. So for this function, f of x, I have 1 over x cubed plus 3x minus 4 times the derivative of my inside function, which is 3x squared plus 3. So I have 3x squared plus 3 over x cubed plus 3x minus 4. For this function, we're going to need to use the logarithm rules. It can get a little messy. So let's give us a little bit more room, shall we? F of x equals the natural log of x squared sine x all over 2x plus 1. What do we see going on here? So not only do I have to use the derivative of a limit, right, where I have to put it under 1, I also need to use the quotient rule and the product rule. So I have, here I'm using the limit rule, 1 over x squared sine x over 2x plus 1. Now I have to use my quotient rule and my product rule together. So I've got 2x sine of x plus x squared cosine of x. So this is me using the product rule for this. All of that times my denominator. Now I'm using my quotient rule. Minus 2, which is the derivative of my denominator, times my numerator, I never have enough room, all over my denominator squared. Okay, the only thing I can really do to simplify this is flip this. Remember, if I have any function under 1, it becomes the reciprocal. So I have 2x plus 1 times x squared sine x times 2x plus 1 squared times the hot mess I have right there and as you can see, one of these terms can cancel. So I'm left with 2x sine x plus x squared cosine x times 2x plus 1 minus 2 x squared sine of x all over x squared sine x times 2x plus 1. Next, what if I have the natural log of 3x plus 2 to the 5th? We've got a lot going on here. So the first thing I need to do is remember I have a composite function. So I take the derivative of the outside, and then I take that times the derivative of the inside. Sorry, 5 times 1 to 3x plus 2 to the 4th times 3. That gives me 15 times 1 over 3x plus 2 to the 4th. Logarithmic differentiation allows us to differentiate a function of the form a function raised to another function. And what we do to solve these is take the natural log of both sides. And then we can use the property of natural logs to expand this as much as possible. So I forgot that little step. Let me show you how we would have properly done this. Because we have an exponent raised to a power, one of the rules of logarithms says what I can do is if I have natural log of 6 to the 5th, I can move that to the 5, to the front. So here we wouldn't have needed that 4, but we did need that 3. So I would have 15 over 3x plus 2.